Galileo Galilei. He was a man who taught the world to see. He was born in Pisa, Italy, in the year 1564, into a world teeming with change, old certainties crumbling like ancient stone. The air seemed charged with a new spirit of inquiry, a desire to look past dusty pages to study the book of nature directly. Galileo grew up keenly observant from his earliest days. He was not content with easy answers. He asked simple, profound questions and insisted on testing every idea against hard evidence. His father, Vincenzo, was a renowned musician and composer who saw elegant mathematics in musical harmony. The family home, the lute, and the rustle of books. From his father, he learned the lute, gaining rhythm, pattern, precision. But another language called mathematics. He was fascinated by mechanics, the swinging cathedral lamp, simple machines. He loved to tinker, to build small tools and contraptions by hand. These early passions, music, math, making things, wove his life's work. Artistic sensibility and scientific rigor set him apart. While others debated in lecture halls, Galileo felt an urge to measure. He saw the world not as a fixed stage for divine drama, but a dynamic system of moving parts, governed by discoverable laws. This perspective was revolutionary. It required shifting from accepting texts to proving what could be seen. A philosophy born in the workshop as much as in the library, hands-on, would lead him to challenge the very structure of the cosmos and reshape our place within it. Practical arts and abstract thought made him suited for what lay ahead. Musician training taught him to listen for patterns, while artisan skill let him build the instruments to explore them. He was not just a thinker, he was a doer. He didn't merely imagine, he devised ways to compel the world to reveal its secrets. Before Galileo pointed his telescope toward the heavens, he first turned his sharp gaze to the world right here on Earth. As a young professor of mathematics, he became obsessed with the fundamental question of motion. The accepted wisdom of the day, inherited from Aristotle, stated that heavier objects fall faster than lighter ones. It seemed like common sense, so obvious few thought to question it. But Galileo did. He was not satisfied with arguments. He wanted to see for himself. He designed simple, ingenious experiments to probe falling bodies, speed, acceleration. He slowed falling with inclined planes so he could measure accurately. Lacking a precise clock, he used his musician's timing, his pulse, even a simple water clock. Through countless trials, he found distance grows with the square of time. Ignore air resistance and a cannonball and a feather fall the same, a direct challenge to ancient authority. The turning point came in 1609. News of a curious spyglass spread. Others saw a tool. Galileo saw the universe. He didn't copy it. He improved it, grinding lenses, polishing glass, reaching some 30 times magnification. Then he did the unthinkable. He pointed it at the night sky. Others imagined a perfect orb. Galileo saw mountains, valleys, vast craters. Measuring shadows, he found heights. The heavens were like Earth. Near Jupiter, he saw points of light, 3, then 4, moving night after night, moons orbiting another planet. Not everything circled Earth. A mini-system around Jupiter made a sun-centered cosmos plausible. Venus showed phases. The Milky Way resolved into stars, and sunspots appeared and vanished, nails in the Ptolemaic model. Armed with observations, Galileo championed Copernicus. He wrote not just in Latin for scholars, but in Italian for merchants, artists, and princes. Clear prose, logic, and evidence made him a powerful advocate, and a dangerous one to the old order. In 1632, he published the dialogue concerning the two chief world systems, a conversation among Salviati for Copernicus, Sagredo the open-minded layman, and Simplicio defending tradition. Its brilliance was overshadowed by offense. Simplicio seemed a jab at Pope Urban VIII, once his protector. The Pope had allowed discussion as hypothesis with fair hearing. Many felt Galileo mocked that charge. Uproar followed. Ecclesiastical power turned against the aging astronomer. His path led from lecture halls to the night sky, and into collision with the most powerful institution of his time. The dialogue marked the point of no return. The anger in Rome was palpable. In 1633, the Inquisition summoned nearly 70-year-old Galileo. The charge was grave, vehement suspicion of heresy. Not just promoting a theory, but defying a formal injunction from 1616, forbidden to hold, teach, or defend it. It was a confrontation of faith and scripture against observation and reason. Threatened with torture, interrogated by powerful cardinals. A humiliating ordeal. The outcome was predetermined. On June 22, 1633, he was found guilty and forced to abjure, curse, and detest Copernicanism. The legend lingered, and yet it moves. His sentence became house arrest for life at Arcetri. The dialogue was banned. He was forbidden to publish or receive visitors without permission. Confined, growing blind and old, refusing to be silenced, he poured his strength into discourses and mathematical demonstrations concerning two new sciences, published in Holland in 1638. Not cosmology, but motion, inertia, acceleration, and strength of materials, his most enduring scientific legacy. The book Newton would study and build upon. Experimentation plus mathematical analysis. He made the world quantifiable and gave future scientists their tools. He died in 1642 under house arrest. A life of discovery and personal cost, an influence that could not be contained. His tools opened worlds infinitely large and infinitesimally small. Courage matched intellect. His story is reason versus dogma. Remembered for how he taught us to look. Remain curious, question assumptions, follow evidence. The earth does move, and because of Galileo, so does the human mind.